Hello and welcome to today's lesson, which is on perpendicular and parallel lines. So I just want to have a little look at a graphic first to get us started with this one. So we're just going to move over to here and have a look at this one. Oops, this one here. So here we've got our graphic, okay, and this is the equation of the straight line, and we know that the equation of a straight line comes in the format y is equal to mx plus c. In this case, the m, which is the gradient, is equal to 2, so that means it's got a steepness of 2, and the y, so the c is the y-intercept, which is where it's cut in the y-axis, which in this case is -1, which is down here, okay. Now what I want to do is I want to put a parallel line up, so here's a parallel line, okay. And it's passing through this point here, so it doesn't matter where I put this point, anywhere here, it's going to be parallel, okay? Now, what do we notice that's the same in this parallel line? Well, if you notice, it doesn't matter where I change this point. There's one thing which is changing in the green here. I'll show you, look, here it is. There's one thing which is constantly changing, and there's one thing which is staying the same. Now the thing which is staying the same is the gradient, which makes sense because they're the same steepness. If two lines are parallel, it means that they are the same steepness. So when we've got parallel lines, what it means is that the gradient is the same. I can change this here. Let's change this gradient to potentially 3. So when it's 3 here, there we go. You notice that the gradient is 3 as well. So when two lines are parallel, the gradient is the same. So the gradient in this one is both 3, and it doesn't matter where I change that, the gradient will stay the same. Okay, so that's parallel lines, nice and straightforward. I mean, it's pretty obvious, really. The next thing that's pretty tricky is perpendicular lines. Now, perpendicular lines, it might not be as simple to spot. So if I click perpendicular here, now, it doesn't matter where I change this to, I get this gradient here, which is negative 0.5, okay? If I change to this one, if I change m to, let's change it to potentially 3, let's say. In which case, if it's 3, I get minus 0.33. And if I change it to 4, I'm going to get negative 0.25 at 4. Now I'm going to explain why that is. So let's get back to our preview. Let's come back to here. Okay, so the first thing we need to probably get down in our notes is the fact that got to be careful, parallel lines have the same gradient. So it's probably worth writing this down in your notes. Sorry, excuse my spelling, you know I'm dyslexic. Parallel lines have the same gradient. And this makes sense because if they're parallel, so they're the same here, like so, then the gradient's going to be the same as well. It doesn't matter where you change them, the gradient's always going to be the same. Okay, so parallel lines have the same gradient, have the same m value. Now, perpendicular lines is a little bit different. And this is the one which is a little bit harder. Perpendicular lines have a gradient which is called the negative reciprocal. So perpendicular lines have a gradient which is the negative reciprocal. Okay, you might have heard the reciprocal before, and you obviously know what negative means. Now, reciprocal means, if it's just one number, it means 1 over. Okay, so like if it was the reciprocal of 2, it would be 1 over 2. If it's the reciprocal of 3, it's 1 over 3. However, when it's a fraction, it means that you flip that fraction, okay? It's the same thing if you were to do the maths through. So if I had a reciprocal of 3 over 4, the reciprocal of that would be 4 over 3. If I had the reciprocal of 3 over 5, it would be 5 over 3. But remember, it's the negative reciprocal. Now, there's a couple of formulas which you might want to note. So if I have a gradient of m, let's say, then the reciprocal of this, sorry, I should say the negative reciprocal, shouldn't I? The negative reciprocal of this is equal to negative 1 over m. Okay, so the negative reciprocal of, the negative reciprocal of m is minus negative 1 over m. If I have a gradient of a over b, the negative reciprocal of this one is negative b over a. And we'll talk about that a little bit later. We'll come to that. Now, does this make sense with what I had before? Well, yes, it does, doesn't it? Because if I just quickly go back to this one here, so if I just go back to my gradient here, I've got a gradient of 4, and my perpendicular gradient is negative 0.25. Now, if I think about what the reciprocal of 4 is, the reciprocal of 4 is 1 over 4, okay? Which means that it's 0.25, so negative 0.25. If I change this gradient to steepness to, let's say, to 2, well, what's the reciprocal of 2? The reciprocal of 2 is 1 over 2. The negative reciprocal of 2 is negative 1 over 2, which is the same as saying negative 0.5. So that's where all of this comes from. So it might be worth with this one, maybe getting some of these examples down. So maybe saying examples of reciprocal. Examples of reciprocal. So if it's going to be 2, then the reciprocal of that is negative 1 over 2. If it's 4, it's going to be negative 1 over 4. So remember, this is negative 0.5, negative 0.25. If it was the 2 over 3, it's going to be negative 3 over 2. And if it was 103 over 79, then the negative reciprocal of that is going to be negative 79 over 103. So you flip that fraction and make it negative. Now that's the important start with that. We do need to know all of that to get us started here. So let's now have a look at these questions. I'll make it big so you can see it. So in this first one here, it says write down the gradient of the line which is parallel to the line drawn. Now we've already started to have a look at this. We know that all equations come in the format y equals mx plus c. So any can be written in that format, where m is your gradient and c is your y-intercept. So in this line here, I've got y equals 3x subtract 5. So if I want a gradient to be the same as this, so a parallel, so the gradient of this one is 3. So the gradient is equal to 3. So a parallel gradient would be the same as this, which is also equal to 3. So that one there is example 1. Absolutely super. So example 1, the gradient is equal to 3. Okay, so let's have a look at the next one then. The gradient of a line is 2. What would the gradient of the line perpendicular to it be? So it hasn't actually given us the equation of the line this time. It's just telling us that the gradient is 2. So I know if the gradient is equal to 2, I know the perpendicular is going to be the negative reciprocal of this. So the perpendicular is equal to negative 1 over 2. So it's 1 over, and then it's going to negative in front of that, and that's always going to be perpendicular. Okay, so there's the first two questions, example 1, example 2. Let's just check those answers. So 3 and negative 1 over 2, absolutely brilliant. Remember, that could be negative 0.5, it doesn't have to be that. So let's have a look at this next one then. So the next one here says the gradient of the line is 2 over 3. What would the gradient of the line perpendicular to it be? And the gradient of the line is 1 over 5. What would the gradient of the line perpendicular to it be? So let's have a look at both of these. If you're feeling confident, you might want to have a go at these yourself now. So this one here is example 3. And our gradient in this one is equal to 2 over 3. So our perpendicular gradient, is equal to the negative reciprocal of this. Remember, with a fraction, we just flip it round, which is going to be 3 over 2. And it's the negative of this, so negative 3 over 2. Absolutely perfect. Now, this next one, example 4, says 1 over 5. And perpendicular to this is, again, we flip it, so it's going to be 5 over 1, which is going to be negative. We would never write 5 over 1, because we know that 5 over 1 is just equal to 5. The answer is negative 5 there, like so. Brilliant. Okay, so we've done example 3 and 4. Let's have a look now. Let's just check those answers first. Let's have a little look. Negative 3 over 2 and negative 5, absolutely super. Okay, so let's step it up a little bit. So the equation of a line, which is given as y equals 4x subtract 1. Find the equation of the line that is parallel to L and passes through 0, 6. Now remember, the two things we need when we're finding the equation of the line are the gradient, so m, and the y-intercept c. So it's y equals mx plus c, always. It's always like that. So in this, you notice that it's 0, 6. So actually, we've already got this c value. Our c value is 0, 6. So it's asking for, we need to find out what m is. But remember that m, when these lines are parallel, is the same. Okay, so in this case, if I've got the line y equals 4x subtract 1, and my gradient in this case is 4, if it's parallel, then it's going to be also 4, so m is equal to 4. So in which case, if I'm writing the equation of the line, it's going to be y is equal to 4x plus 6, where my gradient is parallel, the same, and my y-intercept is 0, 6. Absolutely super. Okay, so let's have a look at this one on the right-hand side. Now, this one on the right-hand side is a little bit trickier. Now, when these kind of questions come up, this is how they actually usually come up. I was actually trying to find some more, some trickier ones in past papers as when I was researching this. And I actually struggled to find quite a lot of the harder ones. But that doesn't mean to say that they don't come up. So, find the line which passes through 0, 3 and is perpendicular to another line with the equation of y is equal to 2x plus 1. So remember, we want it in the format y is equal to mx plus c. We actually notice that I've already got the c value because it starts with 0. Remember, if it's 0, it means I'm not going across and I'm going up by 3. So I know what my y-intercept is there. My y-intercept is 3, okay? So my y-intercept is equal to 3. The only other thing I need to know is this gradient. Now, the gradient of these ones aren't the same because it says that these lines are perpendicular. So if I've got y equals 2x plus 1, my gradient of this one is the number in front of that x, which is 2. And my perpendicular gradient is going to be the negative reciprocal of this. So it's going to be 1 over 2 with a negative in front of the negative reciprocal. So 1 over 2 over here. So in which case, if I want the equation of my line, it's going to be y is equal to a negative half, so y is equal to a negative half x plus 3. Brilliant. So negative reciprocal, and then the intercept is 3. Super. So let's check those two answers. So 4x plus 6, absolutely brilliant, that's what we got. And a negative a half x plus 3. Now this one was easier, and the reason that it was easier is because we actually knew what the intercept was, but that's not always the case, okay? In fact, when I was actually looking through these questions, the majority of them actually gave you the intercept, and it's more, when it doesn't give you the intercept, they do come up, but I've seen quite a few of them in mainly A-level and things like this. So this is pushing towards the A-level stuff. These are not easy questions. Okay, let's have a look at this next one. So the diagram shows a straight line, L1, drawn on the grid. L2 is parallel to that straight line and passes through 0, negative 5. Now, this is actually a past paper question. It's 3 marks. It did come up. Now, the thing that makes this a little bit trickier is the fact that we need to work out the gradient first. So I'll make it big for you so you can see it. So maybe pause now and get this one down. This is definitely one we need to get in the remote in your notes. Remember, the only way to learn maths is to do it. Okay, so this one here now is example 7 for me. So I'm going to just draw a little sketch of this. Now the best way to do it is just to pick remember, when we're finding the gradient of something, we need to have any 2 points. And the points that I'm going to pick are this one here, which is going to be 0, 3, isn't it? So 0, 3. And I'm going to pick this one here, which is actually negative 6, 0. Brilliant. Now remember, we create the right angle triangle. We see how high it is and how far across it is. In this case, I'm going from 0 to 3. So the height of this one is 3. Across, I'm going from negative 6 to 0. So across, I'm going by 6. Remember that the gradient m is equal to the change in y over the change in x. So in this case, it's going to be 3 over 6, which in this case will cancel down to, well, 3 goes into 3 once, 3 goes into 6 twice, so it cancels down to a half. So this is the gradient here. And if I want a line which is parallel to this, which means it's got the same gradient, and passes through the point 0, negative 5, notice it's 0, negative 5, so we already have the y-intercept, then the equation of this line is going to be equal to y is equal to a half x subtract 5, where the half is parallel to this line and it's passing through 0, negative 5. Super. Okay, what I'm going to suggest you do is pause now and have a little go at that one on the right hand side. Remember to pick 2 points, any 2 points on there. Off you go. Okay, so let's have a look at this one together then. This is example 8. So remember to draw a sketch of your diagram. We're going up like this and crossing through. Here is 0, 1, and here is negative 3, 0. Super. So when I'm doing this, remember I've got to find how high I'm going first. So I'm going from 0 to 1, which is going to be a distance of 1. And then across, I'm going from negative 3 to 0. So from negative 3 over to 0, which is a distance of 3. So in which case we know the gradient is m is equal to the change in y over the change in x, which in this case is equal to 1 over 3. Super. So what we've got to look at now is we know that the format of the equation of line is y equals mx plus c, where m is the gradient and c is the intercept. Now, luckily for us, they've actually already given us the intercept, which is negative 3. And I know that my gradient is parallel to this one, which means it must be the same. So my equation of the line is y is equal to a third x subtract 3. Now, we can only use this subtract 3 because it's 0, negative 3. If it wasn't 0 something, we wouldn't be able to use that one. We'd have to solve it, okay? Brilliant. So let's check these answers. So a half x subtract 5, brilliant. And a third x subtract 3. Absolutely super. Okay, so let's have a look at some other ones. So if you're feeling quite confident, you might want to have a go at some of these yourself. Okay, they are getting harder now. So let's have a look at this one here then. So this is example 9. I'll make it big for you so you can see it. So example 9. So P is the point 0, negative 1, and Q is the point 5, 9. Find the equation of the line P that is perpendicular to PQ and passes through P. Okay. Now notice that this is 5 marks. This has actually come up on a past paper question before. This is worth loads of marks. It's definitely worth understanding. So the first thing I always suggest to do with these questions is to draw a little sketch. So 0, -1 is down, 5, 9 is up. So I can draw a little sketch which looks like this. So 0, -1, so 0, -1, and over here 5, 9, so 5, 9, like so. And let's draw a line, because remember it's the line which is connecting these, like so, there, like that. Brilliant. Oh, try again. There we go. So, we want an equation line that passes through P. So this is point P. So luckily, I've already got my y-intercept, but it's perpendicular to this. So the first thing that I need to do here is to work out the gradient of this one here. So we see how far up I'm going. Well, I'm going from -1 all the way up to 9, which is a height of 10. So -1 and then plus 9 is another 10. Brilliant. Across, I'm going from 0 to 5, which in this case is 5. Sorry, thinking ahead there. So my gradient, M, is the change in y over the change in x, which in this case, M is equal to 10 over 5, which is equal to 2. Super. Now, it doesn't say that it wants it parallel this time. It says that it wants it perpendicular. And we know that with perpendicular lines, it must be the negative reciprocal. So if M is equal to 2, perpendicular is going to be, well, first of all, the reciprocal is 1 over 2, like so. And the negative reciprocal is going to be -1 over 2. And it wants it passing through P. Now, luckily, P is our intercept anyway, which is really handy for us. So y equals mx plus c. M is equal to this negative reciprocal, which is the -1 over 2x, plus c, which in this case is the -1. So it's -1/2 and going through the intercept at -1. Absolutely perfect. Okay, so maybe pause and have a little go at this one on the right-hand side. I actually think this one on the right-hand side is easier, but okay, so let's have a go at it together then. So example 10. So, some people see diagrams like this and they just skip that question, but it's not that tricky if you know how to do it. It says we've got a rectangle A, B, C, D, and A is the point 0, 1, which is down there. The equation of the straight line through AB, so through AB, is y is equal to 2x plus 6. Find the equation of the straight line through BC. Now notice that it's already given us our y-intercept on here. So if I draw my little sketch here, like I always do. So here's my rectangle. Try to make your sketch better than mine. It's not too bad actually. So this one here is 1. This one here it says is 6 in this case. And A, B, C, D, like so. Now it's told us the equation of AB is y is equal to 2x plus 1. And it wants the equation of BC, so it wants this one here. Now because this is a rectangle, these are perpendicular. So we know that the gradients are at 90 degrees. Okay, so the first thing I need to do is I'm going to need to find the reciprocal of the gradient of this line. Okay. So my gradient of this line is 2. So perpendicular to that is going to be same as always. So 1 over 2 negative. Brilliant. And remember, you've got to have the y-intercept as well, which I do actually have in this because it tells me that it sits. So my equation of the line y equals mx plus c. So y is equal to a -1/2 x plus 6 in this case, because that's where I'm cutting this. Brilliant. Let's just check those answers. 2 tricky questions there. I think that first one was probably harder. So a negative half x subtract 1. Brilliant. 5 marks for that one. You got that right. We're banking those marks. And this one here is y is equal to a negative half x plus 6. Super. 2 marks for that one. I assume that that's an an extension question of something else. All right. So a few more questions to go through. So we're getting a little bit trickier now. Now these ones are your kind of your creme de la creme, your hardest of your hard of these ones, I'd say. They do get harder in A-level, but these ones here are your tricky questions. So this one here is example 11. So a straight line is parallel to 2x subtract 3 and passes through the line 3, 4. Find the equation of the line L. So with this one here, notice that it doesn't give you the intercept. So we've got to find that. We know what the gradient is because it's parallel, so the gradient is going to be the same, but we've got to solve to find that intercept. So my equation of the line in this one is y is equal to 2x subtract 3. So a parallel gradient is going to be the same, so m is equal to 2. The thing I don't know is the intercept. But I do have now the gradient, which is 2, and I have a point, which is 3, 4, which I can use to find out my intercept. Now you've seen this. This came up in equation of, finding the equation of a straight line. So if you don't know how to do this, maybe look at that video first. So I know the equation of a straight line is y equals mx plus c. So y in this case is 4, is equal to m, which in this case is the same as the parallel here, 2, times by x, which is 3, plus c. Let's multiply that out. 4 is equal to 6 plus c. So subtract 6, 4 subtract 6 is negative 2, so c is equal to negative 2. Brilliant. So now I know my intercept. I know it's crossing at negative 2. So the last part is to write my equation of line. So y is equal to mx, so m I know is 2 always, and my c value is negative 2, so it's y is equal to 2x subtract 2. Now you might think to yourself there, why don't I have y and x in? Well, y and x are the variables which are changing, and m and c are the things which are fixed. They're the constants, okay? Super. So we've got another question here on the right. Notice that it's 3 marks, so this did come up on a past paper. Maybe pause now and have a little go at that one on the right-hand side. Pause now and have a go at that. Okay, so let's go through it together then. So, the thing that we need to be careful of here, because people always make this mistake, is to spot that it's asking for the perpendicular of this, not the parallel. So we've got to differentiate between them, okay? So this equation of the line is y equals 2x plus 1. So my gradient of this line, m, is equal to 2. So the perpendicular to this is going to be equal to the reciprocal, which is 1 over 2, and negative reciprocal. So I know that my gradient, my new line, is going to be a negative 1 over 2. So we don't have the intercept, but it tells me it's passing through the point negative 2, 5. So I've got 2 things now. My new gradient is going to be this negative half, and my coordinate is negative 2, 5, which is my x and y. So I can use this to sub into y equals mx plus c to find out my c value, to find my intercept. So here, 5 is equal to negative a half times by negative 2 plus c. Now a negative half times by negative 2, you can do that on your calculator if you want. Half of 2 is 1. Negative times a negative is a positive. So a negative half times by negative 2 is positive 1 there, like so. Brilliant. And then subtract 1, c is equal to 4 in this case. Brilliant. Pick that up a little bit. Super. So we've nearly finished now. We've got our intercept, which is C. We've got our perpendicular gradient, which is the negative half. So my equation of the line in this one is y is equal to a negative half x plus 4, like so. Super. Let's check those answers. So 2x subtract 2, brilliant, that's what we've got. And negative half x plus 4, brilliant, that's what we've got here. So well done, you got that right. So we'll go one more question now. Last question to look at, and this is the trickiest one, I'd say. It says that it's 2 marks, but I assume that's because it's come from an extension part. But this one is the trickiest. So this one here is example 3. If you're feeling super confident, pause now and have a little go at this one yourself. I'll make it big for you so you can see it. Okay. So we've got to do a few things here. First of all, we're going to have to find out what the gradient is by drawing my graph and finding the change in y and the change in x. And then it wants to go from the point -4, -2. So we've got loads of things going on. If I'm honest, if I saw this come up, I'd probably think it'd be worth about 5 marks. This might have actually come from an A-level paper where I got it. Well, these do come up all the time, okay? So here I've got my graph. Let's draw this first of all. I've got my line here like so. I've got some points. Now I've actually labelled some points for us, which was nice. So remember, you always need 2 points. In this case, it's going to be 0, 3. And the other point they've given me here is going to be 8, 5. So 8, 5 there, like so. And if I'm finding the equation of the line parallel to this, I'm going to need that gradient. So remember, my gradient n is equal to the change in y over the change in x. So from 3 to 5 is going to be 3 to 5 is 2 up. And then how far across? Well, it's going from 0 to 8, which in this case is 8 across. So my gradient is going to be m is equal to 2 over 8. Now, how many times is 2 going to 2? Once. How many times is 2 going to 8? 4 times. So I've got a gradient which is a quarter. Brilliant. So if I want it passing through the point -4, -2, well, I know that my gradient, because it's parallel to this, is going to be the same. So m is equal to a quarter. And my point this time is -4, -2, which is not the intercept, because it's not 0 something. So I'm going to have to substitute in. So y equals mx plus c. So y is -2 is equal to a quarter times -4 plus c, like so. -2. Now a quarter of 4 is 1. Make that big so move up so you can see it. A quarter of 4 is 1. So a quarter of this is going to be equal to -1 plus c. Brilliant. Take that one over, so add 1, add 1. -2 plus 1 is equal to -1, which is equal to c. Nearly finished. My intercept is -1. My gradient is a quarter. So I end up with summing it into y equals mx plus c. So y is equal to a quarter x subtract 1. Brilliant. Let's check that answer. So quarter x subtract 1. Brilliant. Okay. These questions are tricky, so it's important that you practice, and this is a real solid higher question, okay? And they do come up quite a lot if you're considering things like A-level and things like that, okay? So I've got some questions for you to have a little go at. So I'll make it big for you. Now there's 2 worksheets here. There's 15 questions in total. So pause now and have a little go at those first questions. Okay, so here's your next set of questions. So have a go at those ones now. So pause now and have a little go at those ones. Brilliant, so let's get those answers up. So mark those in green. Super, so thank you for watching this video on perpendicular and parallel lines. Remember to make sure you're having a go at these questions, because the only way to learn maths is to do it, and have a lovely day.